Hello, good afternoon.
Good afternoon, Miss.
Please, hi everyone. Okay, for today, we are going to discuss about electrochemistry. Okay, I hope everyone sees my slide. Okay, so what is electrochemistry? Electrochemistry is the study of the relationships between electricity and chemical reactions. So it also encompasses both spontaneous and non-spontaneous processes. So to deal with electrochemistry, we have to know or learn how to assign oxidation numbers. Oxidation numbers are used or assigned for us to keep track of what element or compound loses electrons and which of them gains electrons. So, if the oxidation number if the oxidation number increases, then that element is oxidized. And if the oxidation number decreases, that means that the element is being reduced. So what are the general, how do I say it? General rules in uh, assigning oxidation number? So we have a list of rules. So don't worry, class. I will post this in Yuha modules. Okay. So general rules in assigning oxidation number. Rule number one, for neutral compound or compounds without kanang charges, all oxidation numbers must add up or equal to zero. Next, if we have ions, okay, those which have charges, all oxidation numbers, all oxidation numbers must add up to the charge of the ion. Third, free elements, all free elements sa imuhang reaction, they should have oxidation number of zero. Okay? For example, if sodium ra ang gabutang, so zero na siya. Don't worry, we will have an example after I state all the rules so that we will know how to apply these rules. Fourth rule, your fluorine, okay, or your symbol element F should have an oxidation number of -1. All elements under group 1 sa inyong table should have oxidation number of +1, while all elements that are in group 2 sa inyong periodic table should have oxidation number of +2. Hydrogen, if you pair it with non-metals, the oxidation number of hydrogen is +1. But if you pair it with metals or boron, so the oxidation number of hydrogen should be -1. Next, oxygen. have an oxidation number of negative 2, except when it is paired with fluorine or peroxides. And last, all elements under group 17, so 7A sa inyong periodic table, they will have oxidation number of negative 1, except sa atoms such as Cl, Br, and I, when they are bonded to oxygen or fluorine. Okay, so again, oxidation and reduction, they form what we call a redox reaction. So a species, we call this a species is oxidized if that certain species loses electrons, and a species is reduced if it gains electrons. So let us consider the reaction zinc, which is in solid form. We add 2H plus in aqueous solution. It will yield zinc 2 plus, which is still in aqueous, which is already in aqueous solution, plus H2, which is in gaseous state. Okay, so rule number 1, free elements, oxidation number should be equal to 0. So your zinc has an oxidation number of 0. H, your hydrogen has an oxidation number of plus 1. And now here, zinc, your oxidation number here becomes 2 because of this. And H2 is now 0. Okay, wala na siya charge dira. Okay, so here, which is oxidized and which is reduced? We see that zinc loses 2 electrons. So from 0 to positive 2 iyang charge, forming the zinc 2 plus ion. So we could say here that zinc is oxidized. While you see that your H plus, it gains an electron from plus 1 to, it forms H2. Okay, which has no more charge. Okay, so we call H plus as the species that is being reduced. The oxidation agent causes something else to be oxidized. So in this formula, H plus causes zinc to oxidize. So we call your H plus as your oxidizing agent, while vice versa, your reducing agent causes something to be reduced. So what causes H plus to be reduced? That is your zinc. So zinc is your reducing agent. So another example, we have the nickel cadmium battery or NiCad battery uses the following redox reaction to generate electricity. So cadmium in solid form plus your nickel dioxide plus 2H2O, which is in liquid form, yields CdOH, 2 solid plus Ni OH2, which is in solid form. Okay. Identify the substances that are oxidized and reduced and indicate which is the oxidizing agent and which is the reducing agent. First, here again, we are given a redox equation and asked to identify what substances are oxidized, what substance is reduced, and know which is the oxidizing agent and the reducing agent. So first, we use these rules in order to determine and assign the correct oxidation states or oxidation numbers to all the atoms and determine which elements change oxidation state. And second, we apply the definitions of oxidation and reduction. Okay, so first, assign your oxidation number. Okay, again, free elements such as CD, the oxidation number should be equal to 0 as you see in rule number 3. So this is 0 plus your O2. You can see here that your oxygen should have rule number 7. Oxidation state is equal to -2. And that's why this is -2. But there are two oxygens. So 2 times 2 is equal to -4. And rule number 1 states that neutral compound, the sum of all oxidation numbers must equal to 0. Okay, so what do we add to -4 so that it will be equal to 0? That is plus 4. Okay, so that is the oxidation number of your nickel. Next, your H2O again. So O here is -2. Your hydrogen has plus 1. So check if it counts. So O -2, -2 plus 2 H atoms. So 1 times 2, -2 plus 2, it is still 0. Okay, so we did not violate any rule. Here on the right side, so H is plus 1. Okay, 1 times 2 is 2. O is -2. So -2. Oh, this is not the correct formula. Wait. It should be CDOH na ang 2 nasa gawas. Okay, so 2 times 2, 4. 2 times -2. Your oxygen in total has -4. So -4 plus sa 2 sa oxygen, that would be equal to -2. So what should we add so that everything will have 0 charge? It's +2. So your CD will have +2 nga oxidation number. Okay, let me just erase this para di ma-confuse. Next, the same. This should be OH and 2. Okay. This should be plus 1 and this should be -2. So the same lang sa atong gibuhat sa CdOH2. Nickel should then have +2 oxidation state. Okay, now that we have all the oxidation states listed, let's analyze each atom, okay, each reactant. So the oxidation state of cadmium, 0, increases from 0 to +2. And nickel, from sa nickel dioxide, from +4, it decreases to +2. Thus, your CD atom, it loses electrons. By definition, when you lose electrons, your CD atom is oxidized. And next, because it is oxidized, it is then what we call our reducing agent. The oxidation state of nickel decreases as NiO2 is converted into NiO2H 2. Thus, your NiO2, it gains electrons, and by definition, when you gain electron, you call that species reduced, and this is your oxidizing agent. So nickel dioxide is the one responsible for oxidizing CD. That's why that is your oxidizing agent. Cadmium is the one responsible for reducing NiO2. That is why you call it your reducing agent. Okay? Now, we write half reactions. Okay? Half reactions means in a certain reaction, we separate our oxidation and reaction nga process. This is used to balance them all together. For example, when SN2 plus Fe3 plus react, it yields SN4 plus and 2Fe2 plus. So this is not yet balanced. So the oxidation nga part So again, the oxidation nga part here, your oxidation half reaction is your SN2 plus, which is in aqueous form. It will yield SN4 plus, and reduction, that will be Fe3 plus in aqueous form. That will yield 2Fe2 plus in aqueous form. This here and these are not yet balanced. Okay, so how do we balance redox equations? Okay, so let me okay, so this is from Pearson's. They listed already a summary of how you are to balance your redox equations. So this is the half reaction method in balancing. First, two half reactions are separated. So you separate the oxidation and reaction. Next is first balance atoms other than oxygen and hydrogen. Because we balance, if ang oxygen ang ato i-balance, we use H2O or we add water to the equation. And if we balance hydrogen, we add H plus to the equation. Next, add electrons to balance the charges. And next, multiply by the common factor so that we could make the electrons in half reactions equal. Next, we combine the half reactions nga atong get separate but the balance already. Next, we simplify them by dividing by common factor or converting H plus to OH minus if ang solution is basic, okay? So sa acidic nga part, but if basic is we add OH minus, and then double check the atoms and charges if they are balanced. Okay, for example, we consider the reaction between MnO4 minus and C2O42 minus. So MnO4 minus plus C2O42 minus, it will yield Mn2 plus CO2. So assigning oxidation numbers, again, for oxygen has minus 2, so 2 times 4 is negative 8. So we have here a minus 1. So dapat, what will we add to negative 8 to get negative 1? Then that is plus 7. Okay, so your manganese has plus 7 na oxidation. Next, your C is oxidized. So again, 2 minus 2 gare, 2 times 4 is 8, but you have a net charge of 2 minus. So what do we add to 8 to get 2 minus? That is 6. Okay? So negative 8 ni siya. Again, negative 2 times 4, negative 8. Negative 8 plus 6 will already yield 2 minus. But you see nga, duha ni siya ka C. So each C will have oxidation number of plus 3. Okay? So that is their oxidation numbers. Next, first step of balancing the redox reaction, separate the oxidation from the reduction reaction. So which element or which reactant is being oxidized? So that is C2. Since plus 3, nahimo siyang plus 1. Okay, so C2O4 is your oxidation half reaction. Oxidation half reaction. All right, so we copy it. C2O4 2 minus CO2. So to balance the carbon, you see that we have 2 carbons here, but only 1 carbon here. So what do? We add a coefficient of 2 sa other side nga nanginahanglan og carbon. So that will give us C2O4. 2 minus will be already 2CO2. Check also your oxygen. So 2 times 2, that is already 4. Note that your oxygen is also balanced already when you add 2. Okay. So next, we balance the charge. Our charge here is 2 minus, but our charge here is just 0. So how do we balance the charge? We simply add 2 electrons. Okay, so C2O4, 2 minus will now be 2 CO2 plus 2 electron. Okay, so that is your oxidation half reaction. How about your reduction half reaction? So MnO4 minus Mn2 plus. So the manganese here, as you can see, is balanced. You have 1 manganese left and 1 manganese right. We need to balance your oxygen. And I already said sa previous na rule, to balance the oxygen, you will use H2O. Okay, you must add water. So MnO4 minus will be Mn2 plus H2O. However, your oxygen here is 4. Okay, so we also add 4 oxygens. And by adding it, we use the water. So mahimo na ng 4H2O. Now, we need to balance the hydrogen. And as I've stated sa rule, if you balance hydrogen, you add the H plus. Okay, so that will be MnO4 minus. Okay, wait. That would be MnO4 minus Mn2 plus 4H2O. Again, walay na H sa right side, but there is no H on the left side. So, you add how many H? 4 times 2, 8. So, 8H plus. After that, we have already balanced the elements. We now balance the charge. Okay, so we add 5E to the negative side plus 8H plus MnO4 minus yields Mn2 plus 4H2O. Okay, so now we combine the two half reactions. Okay, we combine our oxidation and our reduction. So ang atong oxidation is C2O4, 2 minus, yielding to CO2 plus 2 electrons. Our reduction, half reaction, that is 5 E minus plus 8 H plus MnO4 minus will yield Mn2 plus 4 H2O. So to make the number of electrons equal on each side, we will multiply the first reaction by 5 and the second by 2 to give the least common multiple. Because you see, natay 5 electrons diri, natay 2 electrons diri. So para magpareha sila, so our target electron should be 10. Okay, so we times this by 5 and we times this by 2 para ma-equal ang number of electrons. So this will give us 5 C2O4, 2 minus. This would give us 10 CO2 plus 10 E minus. Sa second nga reaction, 10 E minus plus 16H plus 2 MnO4 minus yielding 2 Mn2 plus 2 times 4, 8 H2O. And then, we add them together. Like, i-combine na ni natong duha. So, for the left side, we have 10 E minus plus 16H plus 2 MnO4 minus plus your 5 C2O4, 2 minus. That will yield, i-combine po nato tanan na sa right side. So that would yield 2 Mn2 plus 8 H2O plus 10 CO2 plus 10 E minus. Okay? So after this, you notice nga, you have the 10 electrons sa right side, I mean sa left side, and you also have the 10 electrons na naa sa right side. Just like how an equation works, we can subtract them, okay? We can cancel them together already, which will give us 16H plus 2 MnO4 minus plus 5 C2O4, 2 minus, that will yield 2 Mn2 plus 8 H2O plus 10 CO2. Okay, so that is already our final nga na balance na nato nga redox reaction. So if you are going to check, okay, how many H are there? You have 16. 8 times 2, that is 16. So manganese, you have 2 Mn. You have also 2 Mn here. Oxygen, naamoy 4 oxygen plus 4 times 5, 20. Okay, if you can count also here, so that would also amount to 20. And 5 C2, 5 times 2, 10. Okay, so that is your final nga, balance nga, redox nga reaction. Okay? For a basic solution, that was an acidic solution. So the equation is, once the equation is balanced, you will add OH negative para makuha ang H plus. Okay? Para ma-neutralize ang H plus in the equation and create water in its place. So if this produces water on both sides, then pwede na po nimo ma-cancel ang water from each side of the reaction so that it only appears on one side of the equation. Okay, so next part, I think I let you read about voltaic cell. I hope you read it, but let's dwell on it a little bit today. So voltaic cell, in spontaneous redox reactions, the electrons are transferred and energy is released. And how do we utilize this energy nga gi-release sa reaction? This energy can only do work if your electrons flow through an external device. And this is what we call your voltaic cell. So this is a simple example of the voltaic cell. You have two electrodes, one anode and one cathode. So per here, you have zinc electrode in 1 mole of ZnSO4 solution. You have the copper electrode in 1 mole of CuSO4 solution. And the solutions are made in contact with each other through this kaning bridge ngari, which is a porous glass disc. And if you measure the voltage or the potential between the two electrodes, you are going to have a reading, which is 1.10 volts for this case. So another illustration for a voltaic cell would be this. Okay, so the oxidation. Okay, so the oxidation always occurs at the anode na part. While your reduction, it occurs at your cathode. So when electrons flow, we know that charges are not balanced. So how do we balance these charges? We put a salt bridge. Okay. Salt bridge is usually in a U-shaped tube, which contains a salt or agar solution. And we use this to keep our charges balanced. So one simple illustration of your voltaic cell would look like this. In the cell, your electrons, they leave the anode and flow through the wire towards the cathode. And cations, they are formed in the anode nimo nga compartment. So as the electrons reach the cathode, cations in the solution are now attracted to the negative cathode. Okay, since nahimo naman siyang the electrons already reach your cathode, ang mga cations sa solution will gradually be attracted diri sa imuhang cathode na metal. The cations gain electrons and are now deposited as metal sa imuhang cathode. Now let's discuss about what we call electromotive force. So one analogy for this is kanang waterfall. Okay, water flows spontaneously, one way na waterfall from a high ground towards a low ground. So comparably, your electrons always flow spontaneously one way in a redox reaction from a high potential energy towards the low potential energy. The potential difference, kaning high minus low, okay, the potential difference between your anode and cathode in a cell is what we call your electromotive force or EMF. This is also called your cell potential. And it is designated as E sub cell. Ang iyang unit is in volts, okay, or V. So 1 volt is equal to 1 joule per coulomb. Okay, so we also have found many standard reduction potentials. So as you see from this list, these reduction potentials for many electrodes, they have been measured and tabulated, and the values are compared to the reduction of hydrogen as a standard. So these are also measured using or under standard conditions. So what are the standard conditions? That is 1 mole pressure should be around 101.3 kilopascal and measured at around room temperature, which is 25 degrees Celsius. So, ang reference sa kani nga standard nga pagkuha sa reaction or reduction potentials is your hydrogen electrode. Okay, let's move to the other slide. So this is the standard hydrogen electrode or simply SHE. So by definition, as the standard, ang reduction potential sa hydrogen is 0 volts. Okay? So standard cell potentials, then, the cell potential at standard conditions can be found through the equation. Standard cell potential is equal to the potential sa may cathode minus the potential sa may anode. And because cell potential is based on the potential energy per unit of charge, this is considered as an intensive property. Okay, so for example, you have this and your E anode is 0.34 and your E anode is 0.76. So E cell is equal to 0.34 volts minus negative 0.76 volts, which is equal to 1.10 volts. So this is your expected na nga potential that you will see sa imuhang voltmeter. And from the cell potential na inyong makuha, you will already know some trends. So the more positive the value of your E red, okay, the greater is the tendency for reduction under standard conditions. Next, the strongest oxidizers, they have the most positive values, most positive nga reduction potentials, while the strongest reducers have the most negative nga reduction potentials. So, with this, kaning potentials, spontaneous redox reactions produce a positive cell potential or EMF. Again, that equation is represented by this minus oxidation. So notice that this is true for all redox reactions, not only for voltaic cells. There is also an associated free energy, which is the measure of spontaneity sa imong reaction. We call that our Gibbs free energy. This is the measure of spontaneity. And the positive electromotive force corresponds to negative nimo nga Gibbs free energy. Okay, so how do they relate? Your del G is equal to negative N Fe. Your N here is the number of electrons transferred. And your F here is the Faraday constant. Faraday constant is 96,485 calorie per mole. Okay, and your E is your cell potential. Okay. Likewise, your del G can also be written as negative NFE or negative RT LNK, where your R is the gas constant and your K is your equilibrium constant. So equilibrium constant, this relates between the products and reactants of a reaction at equilibrium. or with respect to a specific unit. So how do they relate to each other? They are related by this triangle. Okay, so these quantity, the cell potential, your free energy, and your equilibrium constant. So this is their relationship. So again, remember that your del G is equal to del G sin your cell plus RT L and Q. Okay, so negative NFE, we just substitute this is equal to NFE plus RT L and Q. Divide both sides by negative NF. We have E is equal to E minus RT over NF, L and Q. This is what we call your Nernst equation. Okay? And using thermodynamic temperature and if ato siyang i-substitute atong mga constants, atong gas constant nga R and F, your E is now equal to E minus 0.0592 K. 0.0592 divided by N log Q. Okay, so notice that the Nernst equation, this implies that a cell could be created that has the same substance at both electrodes. Okay, so you can just have example nickel at both electrodes, and we call this your concentration cell. Okay, you can already build a cell just using one substance, nickel at the anode and nickel at the cathode. That is what we call your concentration cell. For such a cell, your E cell is equal to 0, but your Q or the reaction quotient, okay, would be not equal to 0. So therefore, as long as the concentration sa imuhang anode are different, then your E will not be 0. So for here, starting is 1 times 10 to the negative 3 moles sa may anode and 1 mole sa cathode. So magsigig pa kag read og value. So for this, if you attach a voltmeter, you are going to read 0.09 volts. But if pareha na gani sila solution or concentration, so 0.5 moles of nickel, 0.5 moles of nickel, then there would be no reading already. So some applications of electrochemistry would be, as what we have discussed, your batteries. Okay? Batteries are portable, self-contained electrochemical power source that contains one or more voltaic cells. So for example, kanin yung flashlight, di ba, more or less, usay two ka mga batteries ang involved. So batteries, there are two kinds of batteries. Primary cells. These are cells nga cannot be recharged already. Okay? They are already dead. The reaction is complete and they cannot be recharged already. Next type of batteries, you call that your secondary cells. These are the batteries that can still be recharged. So another use of electrochemistry is rust proofing to prevent corrosion. And another is the process of electrolysis. Okay, so some examples of battery, we have your lead battery, lead acid battery. Okay, so this is your lead acid battery. The reactants and products, as you can see, are solids. So for this lead and sulfur, you have your sulfuric acid. The potential is independent of the concentrations. However, again, since this is made with lead and sulfuric acid, this is considered hazardous to us. Next type of battery would be your alkaline battery. So this looks like this. Your alkaline battery is most common primary battery. It has a anode, cathode, and a separator between the anode and cathode. So next is the nickel CD, okay? Nickel cadmium batteries. These are lightweight, rechargeable, but since your CD is toxic and heavy, so we replace it with some hydrides. So that becomes nickel metal hydride batteries. So hydrides are being replaced to cadmium in order to lessen the toxicity of your battery. One last example of battery is your kanang mga battery sa inyong laptop. That is your lithium ion battery. It looks like this if you open it. Okay. So these are rechargeable. These are very light and they produce more voltage than your nickel-based batteries. So you will see the electrolyte separates the anode and cathode. The current collectors are on the opposite sides of the panel. So for the anode part, we have the graphite. Graphite are layers of carbon atoms as represented by the black spheres. Dire. And this allows your lithium plus nga ion to move easily from the anode to the cathode. Next, sa may cathode, cathode is usually made up of cobalt oxide layers. So ang cobalt are the red spheres while ang oxide or oxygen, that is ang cobalt is the blue spheres while oxygen is the red spheres. Okay, so mas dako ang oxygen kaysa sa cobalt. And this also makes your lithium ion easily move in and out of the space between the layers. We have another type of cell that is not a voltaic cell, but we call this as our fuel cells. So when a fuel is burned, we created energy that can be converted to electrical energy. So this is from chemical energy to electrical energy. So usually, this conversion is 40% efficient, meaning 40% can be used as electrical energy, while the 60% is lost and is now in the form of heat. But the direct conversion from chemical to electrical energy, this is more efficient and is the basis for our fuel cells. Fuel cells, on the other hand, class, are not batteries, okay? Because the source of energy must be continuously provided. One example of fuel cell is your hydrogen na fuel cell. In this cell, hydrogen and oxygen will form water. The cells are twice as efficient as combustion, and the cells use hydrogen gas as the fuel and the oxygen from the air. Usually, the process is slow, but we add catalyst for the process para mapaspas na nato ang process. Usually, catalysts are PT, platinum, just to speed up the reactions at both the cathode and the anode. So next, one form of oxidation, okay, is corrosion. Okay, corrosion is oxidation, and its common name is rusting. Okay, so you see, the iron is one of the common example of corrosion. So Fe is oxidized at the anode region of the metal. By this reaction, Fe2 plus 2E negative. And then electrons form from Fe. Electrons from Fe, kaning two electrons, they migrate to region acting as the cathode. And O2 reduced at the cathode region by this reaction. And after that, we now have Fe2 plus oxidized to Fe3 plus, which is your rust, and it forms now the Fe2O3 ninyo. So how do we prevent corrosion? So we prevent corrosion using cathodic protection. So, how does this work? Okay. So cathodic protection occurs because zinc is more easily oxidized. So zinc is the metal being sacrificed to keep the iron from rusting. So we put a zinc layer here, okay, or a coating. There is on my part. Zinc is coating is oxidized and it is used as a sacrificial nga metal para dili mag-oxidize imuhang or dili mag-rust imong iron. Another method to prevent corrosion is your sacrificial anode. Okay, kanang gigamit pod nato sa mga pipes, sa mga underground nga pipes. Okay? So a sacrificial anode for this case, magnesium ang imong gibutang. This is attached to the pipe itself. Okay? Attached na siya. And the anode is oxidized first before ang imuhang pipe. Okay, so that is how you prevent corrosion. Now let's go to electrolysis. Okay, more or less this is similar sa inyuhang, how do I say this, voltaic cell. Okay, so this is your electrolysis. So non-spontaneous reactions can occur in electrochemistry if we apply outside electricity used for us to drive the reaction. So the use of electrical energy to create chemical reactions, this is what we call your electrolysis. Okay, so basically sa electrolysis, we move the atoms from one anode, from the anode to the cathode. And this is commonly used, kana ganing magpalimpyo mo sa inyuhang kuan, sa inyuhang mga metals like sa silver and gold. Electrolysis is usually the process being used. Okay? So far, any questions regarding the discussion? Hello? Like questions or concerns? All right. Thank you so much for responding. And that's it for today. See you next week, class. And thank you so much for attending. Bye.
Bye and thank you, Miss.
Thank you and goodbye, Miss.